Okay, so hello, my name is Johanna Björklund, and I'm a computer science researcher. What I do is semantic parsing of media, and this means that we take media, like video, text, images, and then we translate them into a graph-based form that computers can manage. And I'm looking to set up a research arena around this. So if you are in media and are interested in AI or ML, then please connect with me on LinkedIn. And then I'm also the co-founder of 3 companies in digital media that do, well, software tools that use a lot of machine learning.
Thank you. Håkan?
Yes. So my name is Håkan Enqvist. I'm a professor in applied material science at Uppsala University. And my research is spare parts for the human body, like mekonomen type of. We try to make original parts, still very difficult. We'll talk more about that, but I'm a spare part person. I'm a co-founder of a number of companies, also doing spare parts and drug delivery. That's what we do.
Yeah, Alvaro?
So I am also a scientist. I did my PhD in Uppsala, and then after a while working there, I tried to start a couple of startups, and I decided to follow the unicorn dream. So I moved to the Valley. I was working in the East Bay since Series C, the company I was working for, 10x Genomics, and I participated in 4 of the 6 products of that company. And then they did IPO. I saw all the prep of the IPO and everything, and they did IPO last September. And I decided to pack my bags and come back and try to help startups here because, I mean, the ecosystem here is great. It's just that the liquidity is completely different. So I decided to come back to help people and contribute with my expertise either to startups or venture.
Yeah, so just 2 words on me. I'm at Industrifonden. I have a background in research, working with nanotech in a field anyways quite adjacent to Håkan's. Yeah, that's it. So maybe, I mean, just to start off at the science end of things, I would again want to go around the team here and ask you, so what recent scientific achievement in your respective fields do make you really feel like you're living in a sci-fi movie? Johanna, maybe?
Yeah, so in my field, like media, then we see a lot of interesting things being done in generation. So one thing that you can do now is to take a manuscript, just written text, and then you can have a little avatar read this, so it gets the sort of intonation right now. It can see that, okay, I'm supposed to sound sad and slow, but this is joyful and happy. And it can also do body language, so it learns that this is a book, for instance, and this happened in the old days. So sort of you can train an avatar to pick up on human body language. And then you can also like connect this with a media library that finds illustrating videos to go with a manuscript. So just the fact that you see the system with just a text, and then you can do a newsreader that does the body language, the intonation, that has also video to show for it. So you can do a lot with very little effort.
And how is that different from what you could do just like a few years ago?
I think that this is sort of something that is not that fundamentally different. It's just that we have had time to use the technology and figure out what we can use it for. Like, for instance, with body language, it's not a disaster if you make the wrong gesture. I mean, no one will get killed over it, not like with your system. So it's rather sort of the technology finding its application. Yeah. What's really new, which I consider to be sci-fi, which I don't think is very exciting for you, is that we are adding structure back into machine learning. So, like a long time ago, we used to have these rule-based systems that were often manually encoded and said that under these circumstances, the system is supposed to do that. But that was too labor-intensive, so we replaced them with neural networks. But what we're having now instead is that we're taking the rules back in, but then we're adding a neural network as a conductor that says which rule is to be applied. So then we get the best of both possible worlds. So we get transparency and we get AI that we can understand, but we get the same sort of performance as we would expect from neural networks. And that is sci-fi for me, even though sort of it hasn't reached applications yet.
But I'm sure there could potentially be great impact also from that type of approach.
Yeah, I think that this will take the field one big step forward. It will go beyond like just incremental improvements to something that's completely different.
And maybe we can get in on examples later, but Håkan, human spare parts.
Yeah, on the spare parts. I would say the thing that is coming, it's still early, but it will come, it's the digitalization of materials. First step has been the manufacturing. That's already there with additive manufacturing layer by layer. where you can do things in a computer and then ask a printer to print it. But next step will be to give, the materials that I do are relatively stupid. It's just atoms sitting in a row. And then we know we can measure their properties and they can do something, but they're not intelligent and they don't feel anything. In the future, they will feel. You will get a dental implant that would give a feeling, maybe then digital feeling, and then later on also feedback. But this is coming. It's about miniaturization and digitalization of materials. And this is coming in all material science industry, and especially within implants, for sure. And that has to do with a lot of issues that are with spare parts and implants then. It's the revision surgery, when you need to go in and redo. As long as it's doing its job, it's fine. But as long as it's not doing its job, which is a quite big percentage issues, and if you can predict and then also counteract that, it's a huge societal savings in the future. So this will come. And I visited one of the previous discussion. Then I realized that then in fintech there's also regulations. And of course in my area there's a lot of regulations. Eventually this will also, everything needs to be aligned. But I don't know if it's 5 years or 10 years or 15 years, but this will come and it will be huge.
So in my case, when I was thinking about this, is that biology is immensely complex, and that's one of the reasons that I joined this company, because their proposal is to divide biology at the minimum component, which is the cell, and try to understand the cell. So if we understand the cell, we understand how the whole system works, and then we start creating systems biology. So thinking about this in Stockholm, the main thing is the Nobel Prizes. So there have been 3 late Nobel Prizes that has been really meaningful. As a researcher, that's the best validation that you can have. So one of them is the reprogramming of cells. We understand now with a few transcription factors, you can reprogram cells into new states. So you can think that you could reprogram potentially cancer. You can think as well, the second one, it was late year, phage display. So you can actually use bacteria to create antibodies, parts of antibodies, and then actually express them and understand how they kiss each other, cells in receptors and the antibodies that are expressing bacteria. And then there was these 2 guys that understood how 2 receptors could actually unleash the immune cells and attack the cancer. So that was actually the medical prize last year, and that yielded all the immunocheckpoints and so on. So if you put that together, and there is actually an unassigned prize right now, which is the CRISPR technology that will be unassigned, then you start to see that you are in this world where you have all these technical people that can study the algorithms, study the data, together with all the synthetic biologists and everything in this golden area, and it's amazing to work in this field. It is really huge, and lots of capital is moving there. So I wanted to finish talking about 2 persons, actually. One of them is, I don't know if you have heard about her, is Emily Whitehead. She's a small child that she had BLL. So one of these treatments actually was a CAR-T therapy. Then she had a really bad prognosis in chemotherapy and took her out of that. And the other one is Judy Perkins. She was in a really bad metastatic breast cancer. And if you have metastatic breast cancer, that's a dead check. But then they extracted her own lymphocytes, trained them and expand them to attack the cancer. And 6 months after, she was in complete remission, and the cancer disappeared 1 year after until today.
Okay, so okay, that's a pretty concrete example, but where are we, if it's science and sci-fi, how close is that to reality, or, to us in the VC and entrepreneurial spaces that would like to act on it now?
Yeah. So basically, it is a lot of conversations with the scientists. I think that the VC environment should grow more heterogeneous. Like the groups I've been working with, they are composed of many mechanical engineers, chemists, computational biologists as myself, biologists, protein engineers. So I think the environment needs a bit of heterogeneity. And then also, I think it needs more bold bets. More bold bets in research. Sweden is an amazing environment where the IP belongs to the researchers. So I think that that's a great support. In the States where I was, it depends a lot of big ventures and philanthropies.
Okay, Johanna, it's quite fitting that you're sitting in between these guys, because I guess one could, from mathematics, I guess you guys are becoming increasingly important again for, the material scientists and the systemic biologists. So you guys, all of you, what fusion are we seeing here? How important will it be?
Well, from my part, I think that one thing that we should be looking at now is that not only machine learning systems that have a high accuracy and performance, but also that are, economic when it comes to energy. Because like until now, there has been so little machine learning and AI in actual use that energy consumption hasn't been a problem. But one of the companies that I'm running at LEAD, then we try to cover all like published newspapers online. And that means that we have to chunk through a lot of data every day. And this means that accuracy and precision is less important, and what is more important is to have like a many-stepped filter that first sift, like, is this close to something that's sport-oriented? Yeah, it is. Then let's move it up one level and use a finer filter. And I think that as we use more machine learning systems, we have to have this approach to have like sifts that become more and more refined and use more and more energy. And I think that will go for your fields as well when you are chunking through a lot of data.
So Håkan, what are you seeing on that end in your field?
On mathematics?
No, on the use of digitalization more specifically, or like maybe simulating new materials in order to create them.
Sometimes I feel, material science, especially in Sweden, is an old traditional, with the oak tables thick, and so it's an old. We are good because we have the iron ore in the ground. So I think it's also driven slightly by fear. All of this, we are traditionally, how to make a metal melt, and then suddenly it's supposed to be AI, applied mathematics. Those get hired very, very quickly from the university. Few of them take their final exam. They get hired by companies very early because of this. So it's a convergent technologies, but it's also the competence behind it, who could see all of this, who can get all of these bits and pieces together, and then you have, from the bigger company side, maybe a fear that what they have built, all their competence, they need to add so many other competences that goes maybe quicker in biology and what it is in material science. Yeah. So it's complicated, and also complicated from the research point of view, because we get funding by colleagues in a way, and then we get funding by saying what the colleagues normally have said. But we sit there and know, but maybe AI and all of this combined would be a bigger step. Yeah. Those who get this in order will win. Get all of these bits and pieces in order will win. In a way, win meaning make a big advancement. Yeah,
yeah, but it sounds like what you need is multidisciplinary teams, and maybe that also goes for like within startups to be able to achieve.
Exactly. So if for a startup, or it needs a conglomeration of startups that have complement. It doesn't need to be one. It could be collaborations among. How now that is run as a business, I don't know. Yeah. But it could be like that as well. Yeah.
Yeah, I think also a common theme within the deep tech space currently is that biology and technology will unite. But also, if you could think about it in a different way, it could be more also that biology will be increasingly important for technology. Because I mean, when we had a chat the other day, you were talking about how today you can actually use bacterial factories for antibodies, and that's just one example. I know you could use it for certain material production too, or food production, and maybe then we're venturing into like the more synthetic biofield. Could you talk about that a bit?
Yeah, I could talk about that. So actually, you all know Novo Nordisk. One of the main products of Novo Nordisk is insulin. So one of the achievements of DNA recombination, it was actually doing that expressing E. coli. So there was a company that capitalized on that. So I could see how we could produce new food in cell systems. I could see how we could create new bacteria that delivers cargo into cells and that stays in your body for a while, kind of like either watching over. There has been actually trials to do that with nanoproduct, with materials and so on. So I could see that coming up in a feasible time. Another thing that I've been thinking really heavy on is, for instance, that ERPA funded a project completely outside of this that we are talking is DNA storage, like the simplest molecular chain. There is a really hot topic as well because the length that you can store information and the security of it as well. But that's kind of like an off topic of synthetic biology and delivery of drugs.
Okay, you had something?
Yes, one thing that's very intriguing is the way nature makes materials. So if I could show you how enamel, your teeth, actually look like, it's so beautiful. The way it's done, it's immense. And if you would ask me, please, could you make, I could describe it chemically, and I can describe it exactly how it looks like, but I cannot make it. Soon, I'm rather sure we can, by the combination of AI, computers, and the new manufacturing techniques. We will be able to make it, and then properties will go like 10 times better, because we perform much better than what we should. If I would make us with a spare part, we will never be as strong as we are. So it's immense how beautiful it's made, and we can study it, and but we haven't been able to make it. Soon we will be able to make it, and there are papers coming with bits and pieces. Now it's like nanotechnology things, very small pieces, but it's so beautiful, and it immenses the properties a lot. So that's another thing that will also come with the combination of biology and AI and the new manufacturing techniques.
So what is your opinion then? Do you think that is viable at a scale?
It will be. It will be, especially for what I know most is the new pieces of tissue that will be very, very close to what we are ourselves.
Yeah.
You know, genetically, it could even be myself that
Yeah.
put back.
Yeah.
And it's from intellectually, it's super beautiful, but it has a function that will be much, much better than what we can do today.
And I guess then we're getting in on this, the smarter part of tissue engineering. It's a little bit funny because I was listening to another talk on tissue engineering or the state of tissue engineering today, and actually we can only complete quite simple organs like windpipes or bones, and some private male organs apparently is also viable today. But I mean, I guess it's gonna, because you need to get that biochemistry in order too, right? To make
it's
it
a
alive.
combination of many competences. But if you see all the technologies rising and combining, you will be able to make it. And today there are very small pieces that you can say, okay, it's actually very close, but it still needs to be scaled up, and it's a long way to do it into a product. But the thinking is there. Yeah,
and I know that you guys are pushing currently the unification of additive manufacturing and biomaterials. What is that?
It's making patient specific. Normally, if you need a spare part, you go to the OR and they have like a toolbox with screws and plates and rods, and they hope that they have something that fits your size. Nowadays, they can make it specifically for you, and you can also design it from a chemical point of view. This is already out there, and it will continue to grow. And I think it's also a business thing. There, I would say it's a business model thing, how to make it affordable for more people. It's still very expensive, and it's very specific at the moment, where it's more let's say, expensive pieces of a skull bone or a jaw bone or that type where we are prepared to pay. But soon it will be patient specific, maybe even at the hospitals, that way they can print.
Could one envision the business model spare parts as a service then, rather than Mekonomen?
No, exactly. Yeah, exactly. That's what it would be. Yeah. But it would be. I think it would need to be distributed. It's difficult to have one place where you manufacture and then ship it.
Sure.
Because of the cost structure and so on. In a way, it needs to be thought through that it needs to be a distributed model.
Yeah. And that works with additive manufacturing, I guess.
Exactly. With additive manufacturing, it would work. And you get the recipe and you follow. It's like Starbucks.
Yeah, I'm getting a time out note from there. So thank you very much, you guys, for listening. And I guess I'll give the scene to the next speaker.